Let's get right into this explainer. Today, we're unpacking a really fascinating academic paper about a massive, frankly, agonizing problem in modern science: vital research data getting completely stuck inside highly secure digital vaults. We're going to look at how a new breed of autonomous AI agents are basically acting as a digital rescue team. They're jumping in to automate complex security checks and ultimately unblock the flow of crucial scientific discoveries. To make sense of all this dense cybersecurity architecture, we're going to break our agenda down into 5 logical steps: the research data bottleneck, semi-automated checking with SACRO, enter the TREvolution, securing AI supply chains, and finally, autonomous agents talking.
So, Section 1, the research data bottleneck, the trap of the airlock.
Imagine researchers working inside incredibly secure vaults. We call these trusted research environments, or TREs, and they're used for analyzing highly sensitive, confidential health data. The problem? Well, it hits right at the exit door, the airlock, if you will. Every single data plot, table, or AI model they try to export out of that vault hits a massive brick wall called OSDC. Historically, this has been a completely manual process. Picture a human compliance checker having to sit down, practically with a magnifying glass, painstakingly verifying that the exported data absolutely cannot be reverse engineered to identify a specific patient.
As you can probably guess, because this manual check is just so tedious, it literally traps vital research. You've got brilliant scientists just twiddling their thumbs waiting for this airlock to clear. So it's not just some expensive administrative headache, right? It actively slows down the pace of life-saving medical and scientific discoveries. Which brings us to Section 2, semi-automated checking with SACRO, building the bridge.
To ease this immense pain, the cybersecurity community built an open-source framework called SACRO. And when you compare it to the agonizingly slow manual checks of the past, SACR is just a massive leap forward. Instead of waiting weeks or months to see if a project violates privacy rules, SACR assesses the risk dynamically, on the fly, right as researchers are actively running their queries. The new workflow looks a bit like this. Researchers use special risk-assessing code libraries in Python, R, or Stata. As they work, the system automatically sniffs out potential privacy risks in the background. Then, it uses a dedicated graphical viewer to cleanly map out that risk profile. It essentially transforms a messy pile of raw code into a clean, highlighted map for the human checker to review. But crucially, SACRO isn't replacing the human entirely. It's designed to act as a highly efficient extra pair of eyes. It severely reduces the cognitive load for human checkers. But as research gets more complex, we have to recognize that this semi-automated bridge is still only part of the solution. Let's move to Section 3. Enter the TREvolution, the next generation. See, as modern research scales up, data doesn't just sit in one isolated vault anymore. We increasingly need to link sensitive data across completely different secure platforms. The TREvolution initiative provides a standardized orchestration layer to handle this. Think of it as the foundational plumbing required to connect different vaults securely. And setting up this modern plumbing, it sets the perfect stage for AI to eventually step in and automate the airlock system-wide. Moving right along to Section 4. Securing AI supply chains, the toolkit. Okay, so here's where things get really interesting. When researchers start training complex machine learning models inside these vaults, exporting them isn't as simple as just exporting a flat spreadsheet. These models are highly complex software products. So the big glaring question is, how do we actually track their safety? How do we prove, beyond a shadow of a doubt, that a trained model isn't hiding underlying security flaws or malicious dependencies before it's released into the real world? Well, the first piece of the puzzle is something called an AIBOM, or an Artificial Intelligence Bill of Materials. You can think of it exactly like a strict nutritional ingredient list, but for software. It meticulously documents every single component, every library and every dependency used to build that AI model, proving its integrity hasn't been tampered with somewhere along the line. The second piece is CSAF VEX, and essentially it acts as a machine-readable security badge that works like a false alarm filter. Let's say an AI model uses a software library that has a known flaw. Well, because of how the model was actually built, maybe that flaw can't actually be exploited in practice. VEX documents instantly tell the system which vulnerabilities are real threats and which are just false alarms. That allows safe models to pass right through without needing a human to manually review every single flag. Finally, we reach Section 5, Autonomous Agents Talking, the Future System. Now, if humans have to manually generate all these complex ingredient lists and security badges, well, we're right back to a bottleneck, aren't we? The real breakthrough here is letting autonomous AI agents handle all this bureaucratic paperwork themselves. And they do this using two key protocols. First is MCP, which acts as a highly auditable rulebook for exactly how the AI agent interacts with local tools. The second is A2A, or Agent2Agent. This is brilliant because A2A allows an AI in one secure vault to securely whisper risk signals to an AI in a completely different institution's vault, all without ever exposing the underlying sensitive data. So, automating the airlock beautifully solves the research data bottleneck. It totally clears the logjam that has held back collaborative science for years. But it leaves us with one highly provocative thought for the future of cybersecurity. By completely replacing human checkers with autonomous AI agents that are talking to each other at the speed of light, we are essentially handing over the keys to the vault. As the pace of scientific discovery accelerates, we really have to ask ourselves, are we truly prepared for a world where AI is the ultimate unsupervised guardian of our most confidential human data?